What's going on, YouTube? My name is Joel Rivera, and it's time to learn something new. So, in today's lab, we're going to be doing a GRE tunnel, and we obviously are moving on from where we had previously. So, we had to expand our network, and I wanted to do a GRE tunnel connection. And so to do that, we use a GRE tunnel connection to connect multiple sites. So I figured, hey, it's time for Acme to expand, you know, to the to Austin, Texas. We're going to say that our first location is in Washington, D.C., and we're going to expand to Austin, Texas. Okay, so that's the scenario I want to go with. And then, like I said, in this lab, we're going to do a GRE tunnel. But before, we got to prep everything. And also, I kind of want to take a second here and explain how I built this this topology. I'm using draw.io, and it's a good web app that you guys can use. It is free. It doesn't cost you a thing. Just type draw.io. It'll take you to that website. Like I said, it's a web app. It helps you do Visio style diagrams, topologies, and whatnot. And the best thing about it is that it uses a lot of industry standard recognized shapes. For example, it has a whole bunch of Cisco stuff, Amazon AWS, Azure, you name it, multiple, like I said, recognized industry recognized shapes and icons, and it can help you write up a topology. I don't use it usually at work because I have Visio at work, but if you don't have Visio, this could be a way to draw up your topology, whether just for your labs or even at work, if you can use the product. Just wanted to share that with you guys. Okay. All right, so now let's start with our topology. So we're going to build out our topology. I already prepped it a little bit. I moved everything to the right. And now we're going to start adding our objects. So first thing we're going to add is a router. Yep, router. We'll just leave the default setup for the router. I will change the name because I want it to be called router 2. Okay, and then after that, we're going to add a switch. Change the icon to a switch. It's going to be SW. The Ethernet port groups, we're going to change that from 1 to 2. So it's going to have basically two Ethernet cards of 4. So a total of 8 interfaces. And after we do that, we're going to add a virtual PC. Let's do a web server. Do we have a web server icon? Sure. Yeah, we do. The web server icon. We'll use that one. And let's create, well, let me change the name of this guy. We're going to call him web server. And then, all right, and our next node is going to be another virtual PC. We can leave it at desktop. Yeah, I'll just leave it at desktop. Let's call him management 2 because it's going to be a management device. Okay, so now that we have our icons, let's do the connections. So I'm going to be following the topology that I created. So our router is going to be connected Ethernet 0.1 to the cloud and Ethernet 0.0 to our switch. Let's go back to that. Let's do that first. So Ethernet 01 to our cloud. And then Ethernet, Ethernet 0 to Ethernet 1 3 to our switch. And we'll do this one. It's going to be on Ethernet 00, the switch to our web server. And Ethernet 01 for this management device that we're creating. All right. So now that we did that, let's add the logical map. So to do that, right, gotta add the picture. Just name it whatever you want. It just has to have a name. More action. No. Logical map. All right, so we have to go down here. Oh, we gotta edit first. Hit the edit button. Node 1 is this guy, router 1. Node 2 is our switch. Node 3, Linux USR 1. That's correct. Linux management. And our Linux server. Okay. And now for our new devices, so router 2. This is router 2. Our switch. Web server. And our management devices. Okay. Oh man. I don't know how to delete. Oh well. It's just going to be extra big, that one. Alright, so we got to turn on all of our devices. Let's do that real quick. Start all our nodes. Okay, so I'm hoping everything is up and running. Give it some time. Okay, type no for the configuration. We don't want to go into initial configuration. We're going to start it. Okay, so now we're started up. Obviously, we are in the user exec mode, so we type enable to get into privileged exec mode. And we need to, in order to configure the router, we're going to need to go into global config. Once we're in global config, let's first change our host name of our router. Okay. All right. Let me pull up the topology behind. Pull up topology behind. Okay. So first things we got to do is we're going to get into our interface Ethernet 01. That's going to be our outbound connection. And just like we did with router 1, we're going to create we're going to get the IP address using DHCP. So to do that is real simple. We just put IP address DHCP. And no shutdown on that port. Should bring up that port, and we'll see. We should see a bring up that port. We got an IP address of 172 29.129.61. So I'm going to write this down here. Yeah, let me bring this up. I'm going to write it down here. So this guy's, let's just write it here. So R2 Ethernet 01, boom, is 172.129.129.61. And then router 1, if I recall, is 129.129. We can do a real quick test on that one to verify, to make sure. So do ping, because we're in global config, we got to type do in order to do privilege exec command. So do ping 172 dot, sorry, dot 29.129.129. That should be router 1's IP address. All right, and we have connectivity. So, all right, they're talking between each other. So in this scenario, let me step back for a little bit. In this scenario, what we're really doing is we're simulating an expansion of a new site, right? So our new site is in Austin, Texas, and let's say we have the same ISP. So the ISP company gave us this IP address, which we use IP address DHCP. Now, normally I would configure the public IP. I just remember this is actually a private IP, but in our scenario, it should be the public IP address that you would be putting there. But we're just gonna, to make it a little bit easier, I use an IP address DHCP on that NAT, and just write it down so that when we have to use it in order to create the tunnel, which we'll do a little bit later, we'll have that IP address ready and available. Okay, so back to configuring. Okay, now that we configured our outbound, man, I keep fat fingering, our outbound interface, we need to configure our Ethernet 0/0, which is our connection to our switch. Okay, similar to what we did in router 1. On router 2, we're going to create that trunk connection between the switch and the router, and we're going to use subinterfaces and encapsulation .1q. So to do that, remember, we need to first access the physical interface and make sure it is not shut. And we're going to put no IP address because we don't want it to have an IP address. Okay. So next thing we're going to do is actually go into the subinterface. So for this lab, I'm creating VLANs 15 and 21. So Ethernet 0/0.15 will be the first one of our subinterface. And we got to remember to set it to encapsulation.1q with the VLAN ID that we're going to use, which is 15. And now we set the IP address. So that one should be the gateway of that is 192.168.20.62. It's on my topology. And then it is going to be a /26. So that is a 255.255.255.192. We stop real quick with there. So if you guys want some subnetting exercises, we can do a little bit of a lab where we do subnetting exercises where I explain subnetting a little bit on on how I do it. I know it's one of those topics that kind of scares most people once they're getting into networking. So if you want me to do that, write down in the comments down below. You're interested in seeing subnetting. I do it a lot in my head most of the times. unless I'm really tired, I'll probably write it down on a piece of paper. But for the most part, I do it in my head because I've been doing it for so long. But I understand when you're getting into networking, when you're learning, subnetting can be one of those topics where it's kind of throws the newcomers off a little bit, and I understand that. So if you are interested and want me to do a lab or exercises and where I explain how I do subnetting, go ahead and write down in the comments down below. And obviously, please, like the video and hit that subscribe button. But write down on the comments down below that you're interested in subnetting, and if you're interested in me doing a video on building a topology on draw.io, go ahead, write it down below. It's the only way we can get better is if you guys share with me what you need me to work on, or what you're interested um, in me providing for you guys. Okay, so go ahead and write down below what you want. Okay, so let's go back into our lab. So interface Ethernet. So our next one is 0/0.21. We have to make sure that is encapsulation.1q.21. And then we're going to set the IP address. So 192.168.20.94. And then this one is a /27. So that's a 255.255.255.224 subnet. No shutdown. Okay, let's verify that we have. Okay, good. Up. So on the router for now, we're going to stop right there for a router. Let's move on to our switch. Pop over here real quick. Logical map. Bring that down so you guys can see. Okay, enable first because we're in user exec mode. We type enable to get into privileged exec mode. Then we're going to type configure terminal to get into global configuration mode. First thing we need to do is change the name of this. I'm going to call this switch 2. All right. Now we need to create those VLANs. So we say we're going to create VLANs, VLAN 15 and VLAN 21. VLAN 15 is going to be our servers VLAN, and 21 is going to be our management VLAN, similar to how we had it at our first site. So we're just going to type VLAN 15, and the name is servers. Move on to the next VLAN, VLAN 21, and the name is going to be management. All right. Okay, so now that we did that, we got to move on to creating the trunk that's going to head back to our router. So that's going to be on Ethernet 1.3 in my lab. So Ethernet 1/3. The we need to obviously set it the encapsulation. So switchport trunk encapsulation .1q. And this is going to be a trunk. So switch port mode trunk, and then switch port trunk allowed VLANs 15, 21. So VLANs, we're going to allow VLAN 15 and 21. All right. Oh, I wasn't done. Didn't mean to do that, but okay. Now that we created that trunk, we need to do our access ports. And it looks like Ethernet 00 is our access port for the web server, which is on VLAN 15. So let's do that one first. Interface Ethernet 0/0. Switch port switch port mode access, switch port access, VLAN 15. Alright, and then we're going to go to that next port. Man, I'm not typing well today. Ethernet 0/1. And that one is also going to be a access port. So switch port mode access. And then switch port access VLAN 21. Okay, now that we did that, should be done with our configuration on our switch. Let's move on real quick to our devices here. So move that here. So set PC name. One of the problems that that a virtual PCs on EVNG, and actually I think GNS3 has the same problem. The host names, they only limit to, I believe, 5 characters. So I'm gonna just call it web server. Maybe it's 6. Okay, so it took 6 characters. So web server is fine. Okay, so IP, and then the IP address of this device is .1. So on VLAN 15, so 192.168.20.1. It is a /26, which is 64 IP addresses, 62 available IP addresses usable. And then our gateway is going to be the last available IP on that subnet, which is 192.168.20.62. And I'm going to do a quick test to the gateway, make sure we have communication back to our router, which we do. So, okay, great. And now we're going to move real quick to this other management device. Bring this a little bit centered here. Set PC name. We'll just call this one USR-2 user 2. And we gotta set the IP address, so it's 192.168.20.65, if I recall. I'll verify, yes, 65, because it's the first available IP on that subnet. And it is a /27, and then the gateway is 192.168.20.94. Okay, so let's do a quick test to our gateway, make sure we have communication back to our router. We do. Okay. And now let's do a test to the web server's IP, which is 192.168.20.1. Just to make sure that we have communications between the different VLANs through our router, which we do. So we are good on our LAN. Austin, Texas is now up on its LAN, and it does have a connection out, but we need to be able to start communicating with both sites, and we can't at this point. We're going to need to first create a GRE tunnel. So let's explain what a GRE tunnel is first. So GRE, or generic routing encapsulation, I believe. Yeah. Generic routing encapsulation tunnel is a logical connection that you will be using to connect these two sites. So Washington, D.C. and Austin, Texas are going to be using this GRE tunnel. It's a logical connection, meaning it is not a physical connection. We're not actually connecting from our router a physical line all the way from Washington, D.C. to Austin, Texas. It just doesn't make sense. So the logical connection that we're using is basically through the internet connection, through our ISP. We're going to have it basically create a connection between each other, between each sites. Okay, so when you use a GRE, we're going to need to, let me go back to here where I can actually draw. In order to do a GRE, you're going to need three things. Okay, so first you're going to need to set the tunnel IP. Then you're going to need to identify the source. So the source is basically how does that router, that device, get to um, the connection. So we only have one outbound connection for router 2 and the same for router 1. So the tunnel source on router 2 would be, tunnel source is going to be that interface, which is Ethernet 0/1. Learn how to write. Okay. And our tunnel destination, the third thing we're going to need is our tunnel destination. So tunnel destination is going to be the IP address that belongs to the router that we're trying to get to. So for router 2, it should be 172.29.120.1. Let me erase that. I'm sorry. It just looks horrible. Let's start over again with that one. It's going to be 172.29.129.129 because it is the IP address of router 1's outbound IP, outbound interface. Okay? So that is the publicly, well, in this case, in our lab, the publicly IP, the WAN IP for router 1. So that's the destination. So you're basically going to, to create that tunnel, you're saying using this IP address, which the IP address is going to be 10.0.12.2, and using the source, okay, using the IP address, right, which is 10.0.12.2, through the source, which is our Ethernet 0/1, that's our outbound connection, we're going to try to reach this IP in order to create that tunnel, that GRE tunnel. All right. So for router 1, let me just type it. I'll do it over here. So this is router 2's. Let's do router 1. Okay, the tunnel IP again, which, remember, this one is 10.0.12.2. For router 1, the tunnel IP is 10.0.12.1. Its source, so tunnel source, is going to be the same, which is its Ethernet 0/1 is its outbound interface, so Ethernet 0/1. And its tunnel's destination is going to be the IP address, router 2's IP address, outbound IP address, which is 172.29.129.61. All right, so now we should be able to start setting up our tunnel connection. So I'm going to go back to router 2. We'll have to do it on both sides, so router 2 and router 1. So let me also bring up router 1. Let me go back here. Let's go back here. Get this guy up and ready to go. Okay, so start with router 2. First enable it. Go into global configuration mode. Interface, and I believe tunnel 12. I named it tunnel 12. Interface tunnel 12. We're going to set the IP address of that tunnel. So IP address is 10.0.12.2, and it is a /30, which is 255.255.255.252. All right. Now that we have the tunnel IP, we got to do our source. So tunnel source is our Ethernet 0/1. That is our outbound. That's how we're going to get there, right? And then our tunnel destination, where we're going to try to reach. Tunnel destination is 10. Oh no, sorry. Tunnel destination is 172.29.129. So it's router 2. So it needs to be router 1's IP 129. All right, so we're up. I know what you're saying. How could it be up if router 1's configuration is not up? And that's true. We need to do router 1's configuration in order to be fully up, but it's technically up because it has all the necessary parts. So reminded of last time we created an enable password. So this one is Cisco. All right. We're in privileged exec mode, so now we need to go into global config. So type configure terminal to get into global config. And we're going to interface tunnel 12. Give it the tunnel's IP address, which is IP address, and then the IP address, which is 10.0.12.1. And the subnet mask is a /30 or 255.255.255.252. All right, now we need our tunnel source, which is Ethernet 0/1. And then our tunnel destination, because we need to tell where it needs to go in order to form that tunnel. So it's 172.29.129.61. All right. Now, if I do a show IP interface brief, we see the tunnel's IP is up, and it says up. And in order to verify, we're going to do a 10. We're going to ping the 10.0.12.2, which is router 2's tunnel's interface IP. And we're up. So now we have a tunnel. All right. So we're not done. We're going to need to exchange the routes. So I know I haven't covered dynamic routing protocols yet. I'm just going to do EIGRP. I will definitely do a more granular lab explaining the ins and outs of EIGRP, starting from the basics and going forward. But so I'm just going to configure the dynamic routing protocol EIGRP to get both sites connected. So first we're going to do is going to type router. Well, we're going to get into global config. I'm in global config now, and we're going to type router EIGRP. I'm just going to use process ID 1. We're going to do no auto summary. And then we're going to do network. So we need to basically tell which networks we're going to advertise to our neighbor, right? So going back here, I'm going to advertise obviously these. But I'm not just going to do a 192.168.10.0 and then hit enter. I actually like to do the wildcard mask when doing EIGRP. One of the reasons why I like to do that is because if you don't use a wildcard mask, you're gonna allow basically the EIGRP process to assume. And granted, our routes, I mean, our networks are all on the 192.168.10 network, so technically it would work. But I like to separate with the wildcard mask because I like to set the limitations, set the limits of the networks, and because I don't like to assume. And I guess once you get into more advanced topics, you'll probably understand why. But with the EIGRP, I prefer to use a wildcard mask because I set the limit of the network of what I'm advertising. When you assume, uh, mistakes can happen further down the line, and so I don't like to do that. I like to actually dictate with the wildcard mask. So with the wildcard mask, it's just the complete opposite of our subnet mask, right? So in the subnet mask, remember all the bits that are turned on are represented with ones, right? And all the bits that are turned off are represented with zero. Your one bits are your network bits, right? And then your zeros are your host bits, right? So with the subnet mask, you'll have a series of ones. And with the slider notation, it's telling you how many ones actually. So if it's 24, if you see a slider notation of 24, you're actually turning on 24 bits. So the first octet, which is 8 bits, right? That octet is going to be all turned on. So you will see 1 1 1 1 1 1 1 1 1 1 1 1 1 8 ones or 8 bits turned on. And that equals 255, right? So if we're doing a /24, we're doing 24 ones. So 255.255.255 and then dot zero. Okay? Now for the wildcard mask, you actually do the inverse of that. So all your ones will be turned off with the zero. So with our wildcard mask of a /24, it would be 0 8 zeros for that first octet, right? Or represented with the zero. So 0.0, because if we're doing it for 24, so 0.0.0, and then all the zeros will be changed to 1. So if it was a /24, all those in the last octet, that fourth octet, were 0. If you were to turn them on, that's 8 ones, and if you were to add that up, it'd be 255. Again, that's why I said if you want me to explain subnetting, I can go through it and explain it to you guys. Just write down the comments down below. I know it might be a little hard right now, but once you start doing it, you'll understand it better. So with the wildcard mask, going back to our lab, with the wildcard mask, we're gonna be doing the inverse. So we're if we're doing a /26, right? That means out of the 32 bits, 6 of them at the end will be turned on, right? And then everything else will be turned off. So 0.0.0 dot, so say 64, 192. If you were to do the inverse of 192, it'd be 63. Okay? If you don't know how to figure out that last one, it's easy. You take the last octet of that fourth octet, right? Sorry, the last the last number of that fourth octet. So it's a .192 when it's a /26, right? And you subtract 255 from it. And if you don't believe me, I'm going to pull out a calculator, make it easy. So 255 minus that 192, and it's going to be 63. And that's how you get it. Okay? All right. I know that's kind of explaining quickly. Again, if you want me to do a subnetting exercises, please let me know in the comments down below, and I will try my best to explain how I do it. And I do it mostly in my head because I've been doing this for so long. But you know, I don't mind. I want to see. Reason why I do these videos is I actually want to teach people. I want to teach people how to do these things, and I want to learn how to teach. So the only way to do that is by teaching. I know. Okay, going back to our lab. So I'm sorry. I was so excited explaining that I forgot that our first one is not a /26. It's actually a /25. So I made that mistake. Do a no command to reverse that. So 192.168.10.0, 0.0.0.127. Because it's 255.128. The inverse of that is 0.0.0.127. All right. Okay, so our next subnet is our management subnet, and that one is 192.168.128, and then that is a slash 27, which is 0.0.0.31. And then our last one that we want to advertise is 192.168.160, 0.0.0.31, because it's also a /27. And then we need to advertise, obviously, our tunnel subnet in order to create that adjacency with that with the other router. So that one is 10.0.12.0 is the subnet, and the subnet wildcard mask is 0.0.0.3. All right. So that's all we have to do for router 1. Now let's move on to router 2. So let's create that adjacency, that neighborship. Enable global config by doing configure terminal. And we're going to do router EIGRP with a process ID of 1. No auto summary. And then we're to start our networks. We got to identify our network. So 192.168.20.0. Now this one is a wildcard mask of 0.0.0.63. Because it's using the /26 Satter subnet, so it needs to be 0.0.0.63. Okay. And then 20.64 is the subnet IP. This one is a /27, so it's 0.0.0.31. All right. And as we did on the other side, we got to advertise the network connection with our tunnel interface. So that's a network 10.0.12.0 and the wildcard mask of 0.0.0.3. And we should get and we did, a syslog message indicating that we have adjacency, a neighborship with router 1 on our tunnel 12 interface. So now if I were to do show IP route and look for the routes that start with D, as if you need to know which one it is, you can just look at the code up above, which for D stands for EIGRP. So these are the routes that was learned via the router, the EIGRP router protocol adjacency that we did through the tunnel 12 via our neighbor, which is 10.0.12.1, right? So now to test, to see if we have communication, I'm going to do from router 2. Let's try back. Yeah, let's do Linux user 1, which it should be ping 192.168.10.1. And voila, we have communication. So now both sites are connected with each other. Let's go back and let's summarize what we did. Now both sites are connected with each other, right? Through a GRE tunnel. I want to add something. This is a VPN connection, but it is not a secure connection. So in the next lab, I'm actually going to do the securing of that communication, because currently we just have a virtual interface tunnel 12, which is a connection between both router 1 and router 2. But the traffic that actually goes through there is not encrypted, so it's not up to the standards of of where we should be, especially with this day and age with all the hacking that goes on and so forth. So, and then our next lab we'll be doing IPsec, and I also wanted to do similar to what I did last in the previous labs where we natted. We're gonna do the same thing. We're gonna nat. We're gonna nat. We're gonna nat router 2's connection, so that we're gonna do a NAT overload, make sure that our devices have access to the internet as well. Okay, but just a summary. Again, we expanded our network. We added a new site, and we created a GRE generic routing encapsulation tunnel. And we did a simple dynamic routing protocol EIGRP, so that the neighbors are now, so that the routers are now exchanging routes and they know about each other's network. So that's what you would need to do if you were, setting up a new location and expanding on the network. Okay. So I guess that's it for this lab. Once again, please like and comment down below things that you want us to see. If you want me to do subnetting, if you want me to do topology on draw.io, so I can show you an example how we do it. Comment down below. If you have any other questions or advice, or I don't know, if you want to even criticize me, comment down below, on what I can do to improve. But anyways, I don't think we got any more else to say for now, so we'll just leave it at that. Until next time, bye.